Okay, now we've gotten the statistics on the regression. Now we want to diagnose a linear regression. So R fosters the impression that linear regression is easy. Just use the LM function. Yet fitting the data is only the beginning. It's your job to decide whether the fitted model actually works and works well. Before anything else, you must have a statistically significant model. So check the F statistic from the model summary and be sure that the p-value is small. So we had the F statistic here, and the p-value was very small. This means 10 to the minus 16th. So very, very significant. Kind of surprisingly significant. But anyway, so check that. Is small enough for your purposes. Conventionally, it should be less than 0.05, or else your model is likely meaningless. Okay, so let's, well, one more thing. Simply plotting the model object produces several useful diagnostic plots. So in the last video, we did this command. We ran the regression, and then we ran the then we looked at the summary statistics for that. And so this is what we got before. And we stored the regression result in a variable m. So now we can just run plot m, and we'll get several plots. So we get this, the residuals versus the fitted. We get the normal QQ. We get the scale versus location. I'm not sure what that one is. We get the residuals versus leverage. Okay, so let's talk about these, but I'm going to talk about it for just a different set of results, just so that so in this one here, you can see that the residuals versus the fitted are randomly scattered around this fitted line, and that's what you want. You don't want to see any kind of pattern here. It's pretty much random off of this line, so that's good. And the normal QQ, you can't see it very well, but the normal QQ plot are more or less on this line. I'll try and blow that up in a second, indicating that the residuals follow a normal distribution. The residuals follow a normal distribution. That's also good. Here you can see the line just very lightly. The scale location and the residuals versus leverage, actually I'm not quite sure what these mean, but supposedly they're both in a group with none too far from the center, and that's supposed to be good also, I believe. On the other hand, these diagnostics are not so good for regression. Here the residuals versus the fitted plot has a definite parabolic shape. This tells us that I'm sorry, I think I made a mistake before. This line is not what we're talking about. This is the parabolic shape. It's off of this 0 is what we want to talk about. So before, I should have said it's off of this line that things are basically random. Whereas off of this line, things are definitely not random. So it has a parabolic shape, and this tells us that the model is incomplete, and probably you need like an x squared term to capture the parabola. X squared gives you a parabola. So you need an x squared shape. So it tells you that the quadratic factor is missing, and it could explain more of the variation in the y variable. And other patterns in the residuals are suggestive of additional problems. If you have a cone shape, for example, it may indicate a non-constant variance, and so forth. Okay, there are other problems with this not so good diagnostics. The QQ plot here has more points off of the line than before, and then the scale, location, and the residuals versus leverage plots show scattered points away from the center, which suggests that some points have excessive leverage. And another pattern here is that point number 28 sort of sticks out. It's away from the rest here, it's away from the rest here, it's away from the rest here, and it's away from the rest here. So that tells us that that's probably an outlier, and there might be something wrong with it, and we might want to get rid of it, and we can do an outlier test using the following. Now this outlier test is part of the CAR package, so you have to load that first. If you do, for this particular data, you would get something like this. So you would run outlier test on your variable m, and it would confirm that observation 28 is the most likely candidate for an outlier. In other words, it chooses the candidate which is most likely to be an outlier.